Welcome to 6.3. Today we're talking about fractions and decimals on the number line. Alright, so what we're going to do is start out by graphing some negative fractions and decimals, and I should have, we'll keep that one positive for right now. So let's start with number one here, okay, where they want us to graph 3/4, okay, and here's the number line that we've been given, and what we see is that it doesn't just go to 0, 1, 2, 3, 4, 5, no, here's 0 and 1's all the way over here. So the question is, how many tick marks are in between? Well, let's count them, or how many tick marks I should say, to get to 1. So starting at 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what we're going to do with that 8, well, again, I'm just going to call it marks. I'm actually going to change that fraction and make the denominator an 8. Okay, and so what do you do to 4 to make it 8? Well, we remember you multiply by 2, so we're going to do the same thing to the top, because whatever you do to the bottom, got to do the top, and vice versa, and you get 6. Okay, so how does it help us? Well, when we're graphing 3/4, I'm going to go to the 1, 2, 3, 4, 5, 6th tick mark, and that is right there, my 3/4. Okay, now let's go over here. How about negative 1.6? Okay, well, so first of all, it's negative, and they didn't give us a fraction. This time they gave us a decimal. And here's our, number line, and let's see, 1, 2, 3, 4, 5. Okay, so 5 marks in between 0 and 1, and then obviously 1, 2, 3, 4, 5 there, 1, 2, 3, 4, 5 there. Okay, so how does that help us? Well, if we think about it, what goes into 10, right, because we're talking in terms of tenths here, okay, what goes into 10 1, 2, 3, 4, 5 times? Well, 2 goes into 10, right? Okay, so that would mean each one of these little marks is worth 0.2, or in this case it would be a negative 0.2. So that'd be a negative 0.2, that'd be a negative 0.4, that'd be a negative 0.6, that'd be a negative 0.8, oops, and that would be then our negative 1, like that's already there. Okay, so we know that works there, so then what we're going to do is come over and we're going to figure out, well, where's this going to go? Well, negative 1.6, so it's more negative, we would say, than negative 1, but it's not quite to negative 2, so it's lying somewhere in between here. And so we're going to use the same kind of scale over here. So that would be there, negative 1.2. That is negative 1.4. And then there would be our negative 1.6. And then we just mark it and graph our dot and move on. Alright, so now we're going to compare some fractions and some mixed numbers, also using a number line. So we're going to compare negative 1/2 and negative 1/4, and then in here is going to go either a greater than sign or a less than sign. And the way we're going to do that is we're going to construct a number line. Alright, so there's my number line. And we got a negative 1/2 and negative 3/4. So remember, if we went back up here, when we graphed this one, we said, okay, well, the 3/4, and we had 1, 2, 3, 4, 5, 6, 7, 8 marks, so we needed to turn that into an 8. But the problem is here, we have two different denominators. So what we're going to do, in order to correctly scale our number line, we're going to find the LCM, or least common multiple of the 2 and the 4, the denominator. And the least common multiple of 2 and 4 is obviously 4. Okay, so that tells us how many little individual tick marks need to be in between each integer. So if we're comparing two negative numbers, let's see, negative 1/2 and negative 3/4. Well, each of those isn't quite to negative 1. So as I start my first mark, I'll kind of go over here, probably right about there. We're going to call that 0. And then we said we needed 4 marks in between each number. So that's 1, 2, 3, and then that would be negative 1. 1, 2, 3, and that would be negative 2. So to graph negative 1/2, well, I mean, sometimes it's a little easier, right? We can kind of find the right in-between, the in-between point. But we could, again, change the denominator and say I need it to be the same as that number of tick marks, 4. And so negative a half, if the negative throws you off, right now it doesn't matter, so you just put the 4 there. And what do you do to 2 to make it 4? Times 2, same thing on top, and you get a 2. So we're going to move 2 marks to the left from 0. So 1, 2. And there's our negative 1/2. Negative 1/2. Okay. Now how about negative 3/4? Well, his denominator is already matching with the number of tick marks or intervals we have in between. So negative 3/4 isn't quite to negative 1, so he's going to be over here somewhere. So start at 0 and move 1, 2, 3. That right there is negative 3/4. And so as we go up here and we say, okay, let's compare them. Well, remember, when we compare, we're using the inequality symbol, less, greater than, or less than. And we know that the sign always needs to eat the bigger number. So which one is actually greater? Well, when we talk about negative numbers, if we're comparing two negative numbers, it's the one that's closest to 0. So it's actually negative 1/2, even though negative 3/4 is further on down, we would say more into the negatives. All right, so I want you to maybe give this one a shot, try it out, think about how you might do that, just see what happens, and then play the video when you're done. Okay, so I constructed my number line here, partially, and what we need to figure out is, like, first of all, how big does my number line need to be, or how much, how far does it need to span? Well, I got negative 4 5/6 and negative 4 1/6. Those two numbers have to be somewhere between negative 4 and negative 5, right? Okay, they both have a negative 4 as their whole or integer part. So I'm going to come down here, I'm going to mark a negative 4, and then over here I'm going to mark a negative 5, okay? And then, of course, here would be negative 6, and then over here would be, negative 3. But we don't need those to graph these two numbers. And so what we're going to do is, again, evaluate the denominators. So they're both 6. So going by 6, though, that's kind of tough, because our tick marks that we usually do are multiples of 10. And so to go 1 mark over, I wouldn't know quite what that actually is. It would be some kind of probably a repeating decimal. And so we're going to take a little bit of a different approach on this one. Instead of using a decimal, 1, 2, 3, 4, 5, yeah, let's see, 1, 2, 3, 4, 5, yeah, we're going to use fractions, okay? So if this is we got 6 marks in between. If I went 1, that would be 1 out of the 6th, right? Or 1/6. Now, I'm actually going to label that what it truly is, and instead of 1/6, it's, this first mark is negative 4 and 1/6. And then you might get the idea here, that would be negative 4 and 2/6. But of course, what's 2/6? Simplified, it's a negative 4 and 1/3. And then the next one, negative 4 and 3/6, but 3/6 simplifies to 1/2. Okay, the next one, negative 4 and 4/6, but we can also simplify that, so that becomes negative 4 and 2/3. That would be negative 4, and the next would be 5/6, and that doesn't simplify. And then the next thing would be negative 4 and 6/6, but 6/6 is 1, and so we are correct, because that would be a negative 4 plus a negative 1, which would be negative 5. So here we go. So now we can graph. So negative 4 and 5/6 is right there. Negative 4 and 1/6 is right there. So again, comparing two negative numbers, which one is closer to 0? And remember, if that's negative 5 and that's negative 4, then moving on down the line, maybe negative 3, negative 2, negative 1, and then maybe 0. And this obviously is very, very sketchy. But all that to say, which one is closer to 0? We remember that 0 is down here to the right, so in this case it would be the negative 4 and 1/6. He is greater. All right, here's one real quick. Again, I don't think we're going to struggle with this too much, but this just make sure we're going to compare negative 3.08 and negative 3.8 and figure out which one is bigger. Okay, so we could use a number line here, but we could also just kind of remember that something that is closer to 0 is greater than something that is not closer to 0 if the two things we're comparing are negative, and these two are both negative. So negative 3.08, actually let's start here, negative 3 and negative 3, so that doesn't really help us compare. But negative 3.08 and negative 3.8. Okay, so it seems like this is, if pretend they're both positive, this would be like a smaller number. Well, actually, when we're talking about negatives, we reverse it, and this one is actually a greater. But if that doesn't help you, you can set up a number line like this. Okay, so I set up my number line based on tenths, because we had a tenths place, okay, and a digit in the tenths place. So it helps me graph one of them, negative 3.8. Okay, so that'd be negative 3.1. 2, 3, 4, 5, 6, 7, 8. That right there is our negative 3.8. Okay, but how about this one? Negative 3.08. Well, we got to think about what number is that in between. Well, it seems like it's somewhere in between negative 3.00 and negative 3.1. Okay, because it's 8 hundredths. Okay, which is going to be in between 0 tenths and 1/10. And so if I come over here, what we're saying effectively is it's going to lie in between here, which would be this one, and negative 3.1, which would be there. So what you can do, and this is harder on graph paper, but for me, if this helps you see it, I'm going to zoom in, and I'm going to break this up into its own tenths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then that would be negative 3.1. So coming over here, again, we're starting at negative 3.0, and we're going to go to negative 3.1. So that's negative. All right, so that's negative 3 point, not 1, but 0.1. That's negative 3.02, and then I'll keep going. And there you go. And again, what number are we looking for? We're looking for negative 3.08. And so zoom, zoom, zoom. Negative 3.08. Ah, I see it. It is right there. And I'm going to make this kind of extra big so that way when I zoom out I can see it. Okay, so let's zoom out and let's see if we can compare. Well, okay, and that negative 3.08 was right there. Which one is greater? Well, again, which one is closer to 0 when we're talking about negatives? And it's the negative 3.08 right there. All right, here's a little problem about roller coasters. You got a couple drop style roller coasters that look terrifying, and you would not catch me dead on one of those things. This guy's obviously having a good time. And they give us some elevation changes. So what that means with a negative 9.5 feet per second is saying that if they're starting up here, and let's say that's just 100 feet tall, okay, in 1 second they're going to get to there, which is 9.5 feet below the 100. So the actual elevation is, let's see, would be 90.5 feet, because that would be 9.5 feet below where they started. But as far as when we say what was the elevation change, it was negative 9.5 feet because they dropped in elevation, right? If we said the elevation change was 9.5, it would have meant they went up 9.5, but they didn't do that, okay? They got to the top and then they went down. So what we want to know is which ride actually drops the fastest. So this one drops negative 9.5 feet per second. This drops negative 9 2/3. So really, I think what we need to do is compare these fractions. Now, what we're going to do for now is we're going to pretend that they're positive, just for a second, and we're going to write them. Okay, and again, we're pretending they're both positive, and what we're going to do is we want to compare the fractions, so we have to change the denominators of the fractional part. We can leave the 9s. So what's going to be the common denominator for 2 and 3? It's going to be a 6, so it's going to change the 9 and something over 6 and 9 and something over 6. What do you do to 3 to make it 6 times 2? 2 times 2 is 4. What do you do to 2 to make it 6 times 3? 1 times 3 is 3. So what we can do is I'm going to sketch these back in here, and instead of negative 9.5, that's negative 9 3/6, and instead of negative 9 2/3, it's negative 9 4/6. So which one drops fastest? Well, I like to think of it like this. Oh, sorry, I don't know what happened there, guys. This is a number line, or actually, let's do a vertical number line. And here's let's call it 0. Or well, we'll call it 100. Let's call it 100. If you want a ride to drop really fast, you probably, well, if there was a ride that went from 100 to 99 feet in 1 second, that wouldn't be dropping as fast as a ride that went from 100 to 90 feet in a second, right? If it took a second to get from there to there, that one would drop faster. If it took a second from there to there, that wouldn't be dropping as fast, correct? So we want something that covers more ground per second, and so our answer would be this one, that one, or number 2 there. One quick last little problem, guys. Just more comparing decimals. These are both positives, okay? Just want to make sure we're good on comparing decimals. So we always start to the left. Well, the whole part of both of these are 7, right? So let's move on. 1's, same. 2's, same. 4's, the same. Then we get to a 9 and a 3 in the 1, 2, 3, 4th decimal place, or the 10th, 100th, 1000th, 10,000th. That says 10,000, I promise. Okay, and so which one's larger than 9? Now, if they were both negative, there you go. So if they were both negative, and I underline the same decimal place, same exact numbers, except they're negative, then which one would be greater? Well, it'd actually be this one, okay? So comparing two positive numbers, it would always be the opposite as comparing two negative numbers. All right, guys, that's all I got for you. Thank you for sticking with it. I will see you in class.